All right, I'd like to say hello to everyone. It is my pleasure to welcome you to today's webinar, which is part of RENCI's Accelerating Collaborative Team Science webinar series. I'm Brandy Farlow. I'm a research proposal and documentation specialist at RENCI, and I'm also pursuing my PhD in leadership, focusing on components of collaborative team leadership and evaluation in the sciences. Today, we have Dr. Lingfei Wu, Assistant Professor of Information Science at the University of Pittsburgh with us. I'm certainly excited to introduce him to you, but first we want to highlight a couple of housekeeping items before we begin. So we're going to pull up a quick overview of our agenda. Jess, can you forward to the next? Thank you. So this is a quick view of our agenda. We'll take a moment to introduce you to our guest speaker and hear more about the work he's involved in. Then we'll spend time learning with Dr. Wu during his engaging presentation. After that, we'll jump into a conversation prompted by questions from the audience. So just a couple housekeeping items. We have disabled the Q&A for attendees, and all questions related to today's presentation should be placed in Easy Retro, which is our crowdsourced Q&A platform. So we're going to share the link in the chat right now, and Jess will take care of that for us. You may find the platform easy and intuitive to use, and if so, we certainly welcome you to start adding questions and comments throughout the presentation. Please do note, too, that we will share some instructions really quickly to help you out at the end after we're done and before we start our moderated discussion. All right, so let's go ahead and move forward. So let's take a look at how we define team science. Many people use this definition from the National Cancer Institute. Team science is a collaborative effort to address a scientific challenge that leverages the strengths and expertise of professionals, oftentimes trained in different fields. Although traditional science investigator-driven approaches are ideal for many scientific endeavors, coordinated teams of investigators with diverse skills and knowledge may be especially helpful for tackling complex scientific and societal problems. So without further delay, I'd like to introduce you to Dr. Wu. Would you please tell us a bit about yourself?
Yes, I'm glad to be here today. My name is Lingfei Wu. I'm currently affiliated with University of Pittsburgh School of Computing and Information. I'm a computational social scientist. My research mainly focuses on how to measure innovation in science and technology, especially those fundamental radical innovations that change fields, and also how to understand the team dynamics that drive this kind of innovation, which has huge downstream impact in economics and society.
Awesome. Well, thank you very much for that brief introduction. I'm going to go ahead and turn the floor over to you so you can start your presentation.
Thank you, Brandy. I will start to share slides and get into the sharing mode. Is this clear? You see it? So thank you again for all of you to sign up this, and thank you again, Brandy, for hosting this and your colleagues to make this happen. I work on science of team science, which I consider part of the growing community of science, basically evolved using large-scale data sets and machine learning models to answer these fundamental questions about innovation. Now, talking about teams, of course, let's first bring up one of these conventional, very often happen the situation in our research in all stages of our life. But let's start from the perspective of a junior scholar, which is the blue dot, little blue dot here. Now, this junior scholar, could be me still now, has this problem of this choice of should they collaborate with a senior impactful collaborator, which is the red dot here. Now, the motivation for the benefit to do so is very clear. There's a clear benefit because those senior people are usually more impactful, well-established, and thinking about some good problems for research problem for years. So you got to work with the best and most influential. Now, what is the hidden cost here? That is something that usually underthought and under-investigate. And that's my research question. So again, I'm not the first person to think about this, but the data set that they allow us to study this problem better than ever. Actually, since 1960s, there was sociologist Merton talking about Matthew's effect, which is a phenomenon when citation or other forms of recognition, such as rewards and all that, um, awards, they prioritize established scientists rather than their peers, equally equivalent, capable, but younger. And later on, this was studied by Barbarashi and his colleague Albert in the name of preferential attachment. It's all about how recognition prioritize these well-established individuals compared to their junior colleagues. Now, this is well studied, but it was well studied in a time where there was no such uh, phenomenon switch to team science when mostly everyone was doing their own research. And as you see from the network here, nowadays, science is largely defined by team science, by collaboration, as Brandy already introduced. And this brings this new problem, right? The new even more challenging problem of recognition, because nowadays citation and other kinds of other forms of recognition, it does not just go to individuals. It goes to a collaborative work like papers. Now this brings the challenge: how is recognition divided and split between team members who collaborate in that work? And this is even more important recently, because I'm pretty sure like all 35, 40 people in this room are, um, suffer from this problem recently, like thinking about as just as me, right? Thinking about what if one of my work got Nobel Prize? This is a very realistic problem every day, right? What if we got Nobel Prize, and the question is, who will go to take that prize? Now, with that so realistic problem, worry that in mind, I analyzed Nobel Prize data in the past century. And look at this trend, we find the universal trend across this 100th century, where you see the blue dots increase as the total number of work did in that Nobel Prize winning research. And how do we know that? Because when you can analyze the speech of those Nobel Prize winners, and then they will mention the definitive work in their speech. Using this NLP method, we can identify what work actually earned their Nobel Prize and how many people were actually in that work who was not here. So the people who are here in the red dots, which are the final awardees of this Nobel Prize. And those people who did the work are in blue dots. And you can see there's a gap here. I call this gap as a recognition gap in Nobel Prize. And this is enlarged, getting larger and larger in the past century. Surprise, surprise, right? And why? Of course, because Nobel Prize, as much as other prize in science, was designed in the time that science was mainly just pushed forward by individual genius, right? And it has fall behind the practice of today's collaborative work. Right? Now, this emphasizes rationale with our worry that a lot of people do the work in the team will not get recognized, not even when this work is already recognized in the best way, getting Nobel Prize, right? Now, what are the better ways? How can we, is there any ways we can actually look into the what people do in teams, and therefore with the more detailed analysis of do those two things actually get things, right? With that motivation, I start to analyze a special kind of data. Now, this special kind of literature data has an example here. And don't worry if you don't know what this title means and all the formula means, because I have little idea what's going on here, right? I have a feeling that from you, my friends from Ramsey community, have more idea than me on what's going on in this physics problem or AI problem or other problems. But now, a beautiful point of this is that I'm showing this paper by Hoover and Linder from archive. So what's the beautiful thing about archive is that it's the world's largest community in computer science, mathematics, physics, and more, in quantitative biology and more. Right? And when you use archive, you will be recommend to submit the LaTeX file if you are using LaTeX to write a paper to generate a PDF rather than Word. Okay, and at this moment, I'm curious how many of you heard of LaTeX? Can you just raise your hands in the chat room? I won't be able to see that, but Brandy will see that. Oh, actually, I can see that. Beautiful, beautiful. We have 8 people, 9 people, more and more. Okay. And for those who have not raised your hand yet, I'm jealous of your life because you probably never called a nerd whole life, right? That's a very great life that I will happy to enjoy. Okay. So for nerd like me, what does it mean to use LaTeX? LaTeX has this interesting feature that we all use at some point. That is, there are different ways of writing a LaTeX document. For example, you can write as a like write this symbol as 1/2 as everyone else do that in a mediocre way, or you can write it in a little bit personalized way, showing it also here a bit longer. You define it as 1/2 and do this $ and do all these little things. And now you may do that by yourself, or you may just learn it from your supervisor, because people keep copy and paste things. But regardless of how you where you develop this habit or this personal traits from, this provides a very, very interesting and high resolution way for us to know who writes that part of LaTeX. Why? Because we can develop the whole history of one person's LaTeX files, upload to archive, and then by that we can accumulate a personalized database of the unique macros, personalized macros that person was used. And by doing so, when 2 persons meet again and collaborate in one LaTeX file, we can find these personalized macros and attribute them to the potential authors. So the matching algorithm is quite straightforward here. If macro in this current collaborative document appears in your past history, we assume you contribute to that. This brings up this is the effort for contribution, but no worries, we will verify that later on. But bottom line is this gives us this is the first data set in the world, I would say, in large scale that we are able to extract this observational data of who does what in the research teams. Okay, so for this example, we can look at these collaborations between Hoover and Linder, and turns out in the 89 unique LaTeX macros, 40 from Linder and 8 from Hoover, and based on that, sorry, 89 is the total, right? Like 48, 40 and 8 are the unique. And then from there, we can infer the author writing contribution as 5 to 6, 5 to 6 for Linder and 1 to 6 for Hoover. So Linder contributes more in this case. And the beautiful way is like we can do a little bit of visualization to understand what's going on in this algorithm of identifying personal contribution. And basically, you can look at the whole history of Linder in this mathematical symbol space, and as well for Hoover, right? And to verify does this really make sense in terms of people develop, accumulate, and expand the personalized macro over time. And so we see that this is a clear pattern, and there are additional research, if you are interested, can develop from here, because you will see that occasionally people learn or steal the macros from their collaborator. That's the learning benefit of teams, right? So what do we do with that data set? By doing so, we first we create the world's largest data set on observational writing. We basically analyzed the 1.6 million papers to archive by 2 million authors. And from there, we have relatively smaller but still substantially big data set of all these unique authors, about more than 500,000 and 700,000 papers they write, by looking at what do we do in teams. And now, of course, it's time to verify that data before we do anything more, right? So how do we know we can trust that data? The first verification evidence comes from comparing between what they actually do based on our macro data and what they claim they do, right? So we collect all these self-report contribution statements from 4 journals, and turns out great news here. Scientists are honest and trustable. When they say X and Y write the paper, they actually write the paper, right? So it's about 87 overall. It's total is 87% precision that we can trust this data set by cross-validating self-report and observational writing behavior. The second comes from ground truth data. We collect 14 cases of scientists. We were negotiating with Overleaf, but they have private conservation, so we have to go with friends. This is what friends are for at this kind of moment. You go there and you say, can you just give me your data? And if you are good friends, they will handshake, but in the end of the day, they'll pass on the data. That's how you know how many actual friends you have. And so based on that calculation, I have 14 friends who pass me this Overleaf data set, where we can actually analyze the whole history, minutes by minutes, second by seconds, of the editing activities. And by cross-validate that high-resolution individual editing activities against the macro data set we developed, we find it's largely consistent, right? With the Spearman's rank correlation of 0.6. And these things become more interesting if we evolve some face validity here by plotting the relation between contribution and the author rank, and see whether the data set that we developed fits in align with the conventional belief of who does more or less in teams, right? So basically, it just declines. First order contribution is solid here. They significantly contribute much more than all other people in the team. And as team size increase, we have very consistent but a steeper and steeper slope that middle order do less than the first order. So this further builds our confidence in this data set. And this is also interesting when you look at across the research culture and communities, and again, see whether our data set is trustable, right? Because we know that there are different kind of practice of research in computer science, where I believe a lot of our RESI friends and community members are very familiar. Is usually operate in teams, and there's a apparent hierarchy there, because a lot of teams are actually designed before the team is formed, in the way that you need to get the grant first as a PI, and then you recruit team members to deliver the grant once it's awarded, right? So in that way, the first order will do a lot of work, and especially technical work. And when last order, they contribute to the team both to the paper itself and also to grant, to back work, to administrative things. So you see this more clear decline from of contribution within a single document of that latex against the other order. Now, in economics and some other humanity and sociology and social science fields, it's a little bit different, especially in economics. People use alphabet to rank their family names, right? So that would be a huge disadvantage of me. So you wouldn't find me writing economics papers, because in that way, I would never be the first author. I have a family name starting with W, right? So, but here's just to show you that this data set supports and validates our belief of how different fields operate. And therefore, in economics, it's more like random shuffled contribution. You cannot see distinguishment between other ordered in contribution because they're alphabet. But in computer science, that's a team organization. So again, verified, good data. And this is the last piece of verification, but it's more than just verification because it says something new. Now, with this data set, a great benefit is what? Is we can first time in the history look at precisely what people do in different parts of documents. Why? Because in LaTeX, everyone will use this slash section or slash subsection labels to divide articles. And unlike the previous research had to rely on PDF files and other files and extract this kind of information across different practice, we have precise label of where the section of, for example, introduction ends and starts, right? And by that, we can divide people's contribution within introduction, within each section, and we can normalize. Here's the beautiful part. We can normalize everyone's effort. Maybe like you write, you are the first author, I'm the second author, so you write more than me overall and across all sections. But let's ask this question. Within the limited amount of contribution I contribute, I do for this paper, where is my focus? And by that way, we normalize across authors in terms of unique macros, ignoring the absolute amount of effort, instead focus on the relative focus of their effort. And you find a beautiful pattern emerge in the way that you see this clear division between conceptual work and technical work. Those who write more introduction, conclusion, discussion, and acknowledgements are actually idea creator generators, right? They talk about theoretical work. And those who write more methods, results, experiments, and all that are more like first author. So very, very interesting result, further solid, consolidated ideas. Now, I will skip the details here, but we basically use a established algorithm who predicts and verified by this predict who will get recognition in the team if there's only one person get recognition, and successfully verified by Nobel Prize as a credit algorithm by Shen and Barabasi's 2014 PNAS work. And applying that, we are able to calculate both sides of our data, not just for Nobel Prize work and people, but for all the 500,000 people we identify. To refresh memory, now we have both sides of data. We know who is the top or second or third or whatsoever contributors in the team. So we know the blue part. And now we also use the established credit allocation algorithm to see who actually will get the most credit or the second amount of credits in the team. And of course, naturally, is to cross-analyze between them, right? But before we get there, I will just show you this result that even by a pure description, you see huge gap here that the contribution declines with all the rank across all team size, and credit share increase with the team size. So there's something going on, right? Now, things getting very clear and very scientific rigidly when we build this logistic regression to predict who will get the most recognition in the team, the probability, and from who has done the most as the top contributor in the team. And things getting very interesting when you look at other variables, right? Because in ideal world, if science is a merit-based system, no other variables will be significant because what you do predicts what you get, right? But instead of that, we found that a lot of other variables are significant. The most significant one is career age, right? So if you work with the very senior people, that's even more important. They will learn more, get more credit than you, even you are the top contributor, and they are not, right? And other things also matters. As the last author, as a corresponding author, it matters. As a male, there's a little bit premium here that it matters. Doing good work matters a little bit, but not so. publication year has a negative impact because earlier years published papers is easier to, it was more merit based, and nowadays it's less. It's more challenging to identify who will get recognized in the team. And this is surprising because we have already controlled team size in this analysis, meaning that the dilution effect of teams has already been controlled. And so with the same size of teams, like 3% who published paper in 1950s compared to 3% who published paper today, it's easier to distinguish these 3% in the past than the now. It's very interesting to ask why, right? And the bottom line is we show that it's more and more challenge to recognize individuals in teams. And this is very clear when you visualize this effect. And basically the gap of between top contributor and top recognized other is increased when you have larger teams. And so this is pretty much my single research. And in the last few minutes, I like to place this finding of the single study in a broader view and conversation about the benefits and costs of teams. So one of the going on research, this research conversation this has contributed to is about the cost of and benefit of teams in individual creativity, right? So last year there was this paper by Park and colleagues on Nature as a cover that science is getting less exciting. There are less and less big ideas in science. Well, there are many explanations. Of course, we need to keep more validations on whether it is so, right, to establish the fact. But even this is a fact, there are many reasons. And one reason I try to connect and contribute is that because teams are getting larger, and larger teams are on average less disruptive based on our 2019 Nature research, right? Now, this raises the question of why team fails sometimes. And my 2023 Nature paper based on studying remote teams point to the team hierarchy and team size problem. Well, we're putting together not because they cannot be separated, but because they are usually associated in the real world, right? So what team promise us is there are more brains, right? So this is the real data from that paper connecting millions of scientists and collaborations across continents, across 3,000 cities, right? So they are blue when they are highly developing and consolidating previous research using index, disruptive index. We helped develop. That was first developed in technology. We introduced that first to measure science, and we show it in red if it's highly disruptive, right? So basically, you see these global and large-scale collaborations. They are usually come to verify something, to consolidate something. An example is the Human Genome Project, right? When you put the thousands of people together to do the human genome, it's about verifying and use existing idea rather than two-person Watson and Crick in 70 years ago who actually come up with that idea. So this is a fundamental different kind of contribution. Not saying large teams are not important, but saying they important in a different way than small teams in terms of consolidating, right? But this is a gap because when we have had a team promise, we will promise to access to more diverse talent and put different kind of people together. Everyone got to say everything, and then at some point we can find a good way to combine these ideas into creativity, right? So that was the collective brain assumption of the internet and all these information technologies. But what we found is that teams does not behave in that way, right? As you can see from this evidence from that paper, as team size increase, the amount of people who conceive and write, let's call it offensively defined, for example, brains, actually does not scale up, right? You have 3-person to brains in 4-person team, and you still have 3-person doing brain work in 10-person team. So when teams expand and you evolve more people, it's mostly to recruit more people to muscle work for this technical part, right? So that's the experience. It's not really about this fail. It's about when large teams are unlikely to do more innovative work. But The research I just put this into the next stage, looking at the cost of things. And of course, that's not the end of conversation thinking. It's the start of conversation thinking of how can we design better incentives, funding systems, and all kind of institutional support to cover that cost, so we can actually use large teams and do large teams and design large teams, right? So that brings to from the cost from creativity to recognition. We talk about how large teams are unlikely to be creative, and then another cost is they are also will overshadow individual recognition. It divide and dilute who actually do that work and make it challenging to allocate recognition, which is essential piece of scientific reward system and essential piece of everyone's career, especially for junior author, right? So I think my research starting from 19, talking about small teams disrupt, we need to care about different different size of teams playing different roles. To 2020, flat teams innovate, we need to think about how we can design the uh, more flat teams such that more people can actually participate in idea generation rather than just implement. We need to cover the cost of need to support on-site teams even after COVID and after we have this remote work technology, with how we cover travel costs and the basic investment in infrastructure to carry on to support more impersonal interactions for innovation. I think this string of research not just complements in previous research of the benefit of teams in citation impact, in productivity, and I don't know, maybe a higher chance of getting grants, and talking about the other side of the team. And the purpose of doing so is not just to deny the value of large teams, but instead to understand what large team actually takes more than just a bigger bill, right? And to cover the communication and all kind of costs of large teams, so we can better have a team ecology in system. And this all work is impossible with my students, PhD students, Yilin Ling, who lead the 2023 on-site team, remote team nature paper, and Lu Yang, who worked with my research assistant, Jasmine Pei, currently at the Denver University and in the job market, develop the research, the backbone of research of the data set we talk about today in arXiv. And again, I'm Lingfei Wu from University of Pittsburgh, a computational social scientist working on team science and innovation. And I'm happy to take your questions, and let's think about team innovation together. Thank you.
All right, that was really interesting. Thank you so much, Dr. Wu. We really appreciate that. So we would like to hear from the audience now. So we'll go ahead and move to the Easy Retro board. And I'm going to walk you through how to use Easy Retro for our Q&A. So to add your questions, you will click on the plus sign in the relevant column. You will type your idea, and then when you're finished, hit the blue box with a thin line or thin white check mark, and that will actually save your comment or question within the field. Your idea will appear on the screen for the public's reaction. You can also upvote somebody else's idea if you really want to hear that question answered, and that's just the thumbs up icon. And you can also comment on other people's ideas to maybe add to or refine something that you see there, or maybe ask something that's a follow-up. So I believe Jess will go ahead and put the link for our Easy Retro in the chat, and then we will move over there. Wonderful. All right. Sorry about that. All right, so I'll just start with the one that has the most votes, and we'll kind of do them that way. Once we've answered a question, I will move it over to the answered question area, and we will try and keep the ones with the most votes up towards the top, so I make sure I'm asking those. So the first question is, how do we leverage the benefits of large teams without compromising the creative benefits of individuals within those teams?
First, to clarify, I'm not avoiding my responsibility, but it's important to clarify my limitation as a researcher, and that means what I will speak for is mostly the evidence I observed and the thoughts I have. I would love to work with uh, the practitioners who actually teach and work years in these institutions. I cannot address all these questions by myself, and this is supposed to be ongoing conversation. So back to the question itself, um, I think that's I really like this question, and I've been thinking about it. I think the key here is how do we go beyond N? So N refers to the team size here. Indeed, we do have very strong evidence that small team do one thing, innovation, large team do another thing, development or consolidation. Now the question is, how do we make large team innovate? Well, I think uh, if large team can learn something from small team, that would be communication, okay? Because communication is much easier and when you have less people. And now, if I assume that if large teams can maintain the intensity and sometimes unstructured communication and for the quality of communication, they will help them be more innovative. Now, the problem is not that I'm not willing to do so, but it's very huge cost to do so. It means we have to, even have less Zoom meetings, have more in-person meetings, and how many people want to go back to office for that? So I think but that's the direction. If large teams can be innovative, yeah.
Thank you. So next up, I guess, did you find that there was a sweet spot for team size relative to innovation? And how about team size and recognition?
Uh, wow, I thought the question landscape is rapidly changing here. Uh, just want to make sure I get that is the red question or the blue question.
Yeah, it's in the answered question category now.
Oh,
Yeah,
um,
we'll try and keep those up top just in that category just to make it a little easier to um
I think there's something, I wouldn't call it sweet spot or optimized because again, I'm a researcher, I'm not a practitioner. So practitioner and team leaders will think things differently because for them is to how can I get things work in both dimensions, both delivering and both innovating with the results they have. For me, I'm a team scientist, I'm a team researcher. So all I can see is and focus on is the fundamental uh, patterns or principles. And for the evidence, I see they are basically they are trade-offs. If you have smaller teams, they are easy. It's easy for everyone to say their voice, and also because they have less funding burden, they are usually financially more flexible and can survive longer years so that they can afford higher risk versus a large team, big bill, and big funding, and you have to keep produce to justify that. So you're under very different delivery pressure. So I don't know the answer. I would like to learn together, but for what I see is these are two fundamental uh, different directions. To radically innovate is one thing. Um, Small n tends to be better. To deliver to someone to the moon, to observe gravitational waves, to build the next generation AI, rather than just next generation AI idea like Geoffrey Hinton he come up, but the actual implementation of next generation AI, you probably need a lot of things. So I would still see I wouldn't think in the sweet spot way. I would think in the division of labor and different roles to the science way.
Our next question is, what are practical considerations for funding agencies in designing team science programs to ensure a balance in innovation, team size, and credit recognition?
I like this question because I think about that too. I think this talk to the the founding evidence I saw, and in my research, I analyzed how I think I'll just dive into the question conclusion because we have more questions coming up. What I observe is that large teams usually supported by funding, right? Unsurprised. And it's hard for them to innovate. And one reason, in addition to the communication problem, I think it's about the funding pressure. I call it burden of money. When you take that money, you have to deliver. Everyone in the chain is under pressure of productivity. And productivity, in many cases, kills innovation. So therefore, if we can have new funding mechanisms supporting small teams, junior scholars, and even individual scholars, that would be fantastic. Because in that way, we will be able to afford higher risk research, which is fundamentally different from the large team built around established researchers and ideas. So I think we need more venture capital like science funding.
All right, thank you. So next up, what do you think about random author ordering?
Talking about my personal experience, I don't like it because I have a family named Wu. That's a huge disadvantage. But you know what is interesting here in this economic field practice is it's fun to think about that, right? Because they're kind of a system designed you to anti-conjections of who is do the most work. So I don't know how that will change over years because I see even in econ there are more positions like pre-doc and post-doc, meaning that a lot of heavy lifting data work and need to be done by more people. So there will be likely to be expanding of teams and they need to sort out this credit problem. And I don't know how long they can preserve that the practice, but it's a very interesting practice. But the question is that practice going to help and fundamentally resolve the credit problem? I said, I don't think so, because the credit problem here is the contribution is scalable, right? Every time everyone can contribute to something, and then you just need to write down the name and then you are contributing something. But the recognition is unscalable. Recognition is not determined by who does what. It's determined by who will remember that work. And people have very limited memory for general public and for scientific community. So when you face this fundamentally scaling up contribution within every single work and unscalable memory and recognition, I don't know whether you just random shuffle everyone and even more diluting who contribute more will help.
That's fair. So since analysis reveals that team hierarchy is a key factor, can innovation be shaped by changing organizational culture?
Yes, starting from PIs. So in our 2022 PNAS paper, we first analyzed the contribution, self-report. By then, we don't have a data set, as I just introduced. We don't have observational data. So we rely on self-reports. We collect large-scale self-reports from all these journals. And what we observe that even you controlling for team size, a flat team will be more innovative in terms of create more disruptive research with the long-term citations than equal sense the team size but hierarchical teams. And here by hierarchy, I mean the fraction of people who can contribute to, who is acknowledged as designing the research or writing an article. And I call that the ideal generations in the team or brain in the team. And if everyone is brain, or at least more people are brains in the team, even with the same team size, you see the lift in innovation performance. So I think, yes, there are ways. But again, there's a cost, right? Because speaking as a research practice and experience as a PI, if I just divide the work and assign it to my graduate students, it already takes a lot of time. And then now, if you want to evolve your graduate students or PhD students or postdoc researchers together with you to write this article and to design the research, it's unlikely to reduce any of your technical work time and the division of labor time. It will only add to your occupy your research bandwidth, add to your communication cost, and you have more meetings. So again, the real challenge here is we know how to do it, but how much cost we pay to do that? And are we support, as PI, are we supported by funding and institution to do so? If we can do more innovative work by have more meetings with our students in design research and writing articles together, beautiful, beautiful. But that means we'll have slowed down productivity. Is our institution happy with that? We are founding happy to see that in the report. So that's the problem.
Thank you. All right. The next question is, how do you think about team dynamics or output in the context of academic disciplinary silos and interdisciplinary research?
So I like to, so I have this ongoing collaboration. We have archive paper with this Aaron Leahy, a great sociologist who has thought about this interdisciplinary problem for a long time from University of Arizona. And based on her early stage research, her previous research that interdisciplinary teams slows down productivity, unsurprised, and increase innovation. So again, it's a trade-off problem because when you have more people from different fields, it takes more time to communicate. Right? And our ongoing research sees the evidence that you have two ways to organize interdisciplinary teams. One way is that you have, for example, you can hire two people, two headcounts. You can hire two people and they both know, for example, physics and computer science. And they are likely young people, right? Because new people usually have more diverse and exposure and less focus based on the publication record. Now, do you hire them or do you hire a more established computer scientist who haven't contributed a lot of physics and established computer scientists, established physics, right? So this there are many people think about this before. It was called like fox and hedgehog. Hedgehog is an expert, domain-specific expert, and fox is everywhere. Now, what we studied, we control team size and we control everything, the total amount of diversity, as in the case we said, in the end of the day, no matter how you hire these two persons together will cover both computer science and physics. And what we see is that the journalist, the folks, or sometimes we call them the Renaissance thinker or scientist, they have a huge benefit. So the takeaway to have a higher chance to deliver innovative research. So the takeaway here, I think, is that the generalists, the people who knows everything, are more likely it cannot be easily replaced by a few people who knows a little things. So I think that it provides very interesting evidence for us to think more about how to organize interdisciplinary teams. I think the bottom line is interdisciplinary teams, based on early research and based on our ongoing research, it takes time. You cannot be, let me be a little bit honest here. You cannot just see a founding core of interdisciplinary center and then you assemble them in the last minutes. You pull people from different departments and write a proposal. I don't think that's the best practice because it takes time to develop such team.
All right. Thank you. All right, next question. Do you have any thoughts about the value of evolving team membership and team size over the life course of a project as a way to maximize the benefits of brain and muscle?
I'm still digesting what that question means. Does it mean that as time goes, people will get more established and they're likely to have larger teams? And does it mean talking about this reality and based on that, ask what should people do when they already at the second stage and how they can keep innovating.
Yeah.
I will,
I was
I will
thinking
assume that.
about kind of I was taking it to be kind of about the evolution of the team over time. Is there kind of a way to use those evolutions of the team to kind of maximize on both sides of it, right? So like as membership changes, as teams grow or shrink, like is there a way to kind of use that to maximize those benefits?
I don't know. I wish the person who proposed this question can tell me, because I have a feeling that a lot of this question comes from practice and comes from a lot of taxi knowledge of how things actually work. So maybe next time, if we have more opportunity, we can have these open discussions and we can learn this together. Because again, I'm not I'm more like a researcher, and for me, all I can see is just fundamental constraints and principles where you need to have more brains, then you need to have more in-person meetings, breaking the hierarchy, and to have PIs and professors work with the graduate students. But that takes time for the first point, and that slows down productivity for the second point. So can we pay that cost? That's all I can say.
All right. With that, I think that we are out of time for questions. Um, so before we leave, I just want to thank you very much for joining us today. We definitely appreciate your time and attention, and your talk was fantastic. As always, we will be sending a link to the webinar recording by email so that everybody will be able to view it within a few days. Please take a moment to provide feedback when we wrap up in just a moment. And stay tuned for information about our next ACTS webinar. We certainly look forward to seeing you all. My colleague Jessica is going to share the link to join our mailing list in the Zoom chat. Please sign up to stay tuned and learn more.
Thank you,
All right.
Bretty, and thank
Thank
you,
you.
everyone.